one of the goals of blood spatter analysis is to try to find the origin of impact, or the site of origin. The idea is, if I have many, many blood stains, and I can tell the direction that each blood stain was coming from, I can go backwards to where it came from, and there should be only, if it all came from one source, but I have multiple different direction stains, I can now determine where was that source. This is particularly important because, of course, usually victims, when they're injured, don't stay still in this original position. And I may need to know, how was the victim standing? Where were they standing? What direction were they facing? To help me understand the nature of the crime itself. So I may need to know that information. So the area of convergence tells me, where was the victim when they were injured? So this is, and the area of convergence is as if I flattened it down and there's no height, and I just want to say, where on the plane of, of the ground, what location did the blood come from? I don't know how high up it is, but I know it must have all converged from this. And it's simply established by getting all of my drops and determining, making lines of which direction they were coming from, and where all the lines converge is my area of convergence. So let's looking at this picture here. We see that we have this blood drop. So again, it was the tail is telling me the direction it was going. So I go in reverse from the tail back this way, and I do it for every single drop, and I can see that this is where all 4 of these came from the same point. Also, remember, I might have multiple different areas of convergence. So I might have lots of patterns on top of each other where some of them are going to different areas of convergence. That begins to tell me a story as well. So this is one aspect of what a crime scene investigator would be doing, was looking at the pattern and finding the area of convergence. Along with that, we talked about the elongation. So the elongation has to do with the angle it's traveling sideways. It's not traveling straight down. And instead of getting a circular blood, I get an elongated or oval blood. And that oval blood stain pattern, the shape of the ovalness will tell me what direction, the angle it was coming from. So this will give me a sense of height. If I know that it was, it started here and it ended here, and I know the angle, I can use that angle to construct what height it was at. So the angle of impact is going to tell us now the 3-dimensionality of it, and tell us the height that the origin site was. So we use some signs to do this. I know you don't like this, but it's all right. We can do this all with a calculator. The idea is the ratio of the width, which would be, if it was a circle, the width would be the size of the length. If it was completely circular, they would be the same. And that ratio would be 1. As it gets longer and longer, the width to the length starts to get to be a smaller and smaller number. And that I can now take the inverse sine of it. Again, this is using trigonometry, don't worry about it. You can just do on a calculator, inverse sine, but your job would be measuring the width and the length, calculating this ratio, and taking the inverse sine of it to get the angle. That's going to be something we'll work on in class. I understand you need to understand this concept for the test, but you won't have to do this math specifically on the test. So then I now have the angle, and I know the area of convergence. We can use that to reconstruct a 3-dimensional model using string. This is called now instead of the area of convergence, it's the area of origin. So I first find the area of convergence, and then analyze the angles. So then by using protractors and the angles from the actual spatter, then it is lifted, the area of convergence is lifted up until it's at the right angle, and that gives you a 3-dimensional now picture of it. So they call this the string method. There's another video I've shared that kind of shows you more specifically so you can get a sense of it. It's because it's 3-dimensional, it's hard to show on paper.